Hello friends and welcome to another lecture on operation research. Well, there's a problem on your screen now. Just have a look at it. You have three plants A, B and C and their productions are 40, 55 and 80. And the demand from the stores 1, 2, 3 are 70, 65 and 40. Well, the demand and the production rates, they match. But then while you are allocating the products from plant ABC, of course, plant ABC, they make the same products and the same products are, that is only one product, is sent to stores 1, 2 and 3. Plant A, it can send the product to all three stores. But plant B cannot ship the product to store number 2. Similarly, plant C cannot ship the product to store number 3. Now, these are the restrictions that have been placed. Now, the numbers, that is 2, 8, 6, 1, 3, 7, 4, they are the cost of shipping from the plants to the stores. Now, how do you optimize in such a situation where you have a restriction of allocating the sources or the supply to the demands, that is the stores? So, welcome to yet another lecture. Today we'll be looking into transportation problem with restricted allocations. I am Professor Arvind Prasad. We'll be using the Vogel's approximation method here. So let's get ahead. We have the problem once again, and wherever we have the restrictions, that is plant B had a restriction that it could not send to stores number 2. And plant C, of course, it could not send to store number 3. So in that cell, we put M, where M is a very large number. So it reminds us that these allocations cannot be done. So we go ahead and make our penalties on the right column, and in the below, we calculate the penalties. Now, how are the penalties calculated? Most of you must be aware, but I'll just recap. The penalty in any row is the difference between the next highest cost, that is in row number 1 it is 6, and the lowest cost. So it's going to be 6 minus 2, that is 4. Now again, let's take the example of row number B or row number 2. The least cost is 1 and the next highest cost is 3. So the difference is going to be 3 minus 1 and the penalty is the difference, that is 2. Similarly, if we take it for store number 1, the penalty is going to be 2 minus 1. That's going to be equal to 1. Now, all the other penalties shown on the screen are pretty self-explanatory now. Now, in Vogel's approximation method, you take the highest penalty and start the allocation. So, the highest penalty here is 4. Now, if you go to see here, there's a tie in the penalty. You have 4 here in the first row and you have 4 here in the second column. Now, whenever you have a tie, remember one thing, you have to check or allocate in the row or the column which has the least cost. Now, the least cost is in row number 1, where the least cost is 2. So, we go ahead with allocating to row number 1. So, we can allocate 40. From all the production of plant A is now allocated to store number 1. Of course, there is an unmet demand. So we write the unmet demand by putting a slash, and the unmet demand is 30. Now we recalculate the penalties. Now the idea of calculating the penalties is once again the same, but I'll still explain it. Now, since we have given all the production from plant number A to store number 1, we can no longer allocate from this. So the penalties are not calculated for row number 1. So we put an X here. Now the penalty, of course, for row number 2 is 3 minus 1. And the penalty for row number C or row number 3 is nothing but 7 minus 4, that is 3. Now we come down to the penalty of store 2. Now here we need to understand that we have done the allocation in row number 1. So this does not now come into our penalty calculation. We have to remember that rows or columns that have been allocated, once they have been allocated fully, they do not come into the penalty calculations. So now if we have to calculate the penalty, it's going to be obviously 8 is out of picture here. So what we have is 4 and what we have is M in store number 2. Now the difference is M minus 4. 4 is the least number and the next highest number now here is M. It is not 8 because row 1 has been exhausted off. So it is M minus 4. We write M. We do not write M minus 4 because M is a very large number. Okay. So if you reduce just 4 from it, it practically remains the same. So we write here M, and the similar reasoning goes to store number 3 too. Okay. So the penalty here is M. Now again we have come with a tie on the penalties. Now it's M and there's a tie. Now we again select the penalty which has the least cost. Now in this case the least cost is 3. That is in store number 3. 3 is the least cost. So we allocate it. Now how much can we allocate? The maximum we can allocate to store number 3 is 40. So we allocate it from plant number B, and the surplus, that is the surplus out of 65 minus 40, 15 is written down. So 2 allocations done now, more to go. Now we have to again recalculate the penalties. Now remember one thing, plant number A, all the production has been allocated. So that does not appear into our penalty calculations now. Similarly, store number 3, it has been fully allocated 40. So this will not also appear in our penalty calculations. So now the penalty is on your screen, and cross check now. I wouldn't further explain how do we calculate the penalties, but have a look here. Now we have penalty M here. Now we have penalty M here. Again, there is a tie. So we again find out which row or which column has the least cost. Now the least cost here is, if you go to see in row number 2, the least cost is 1. But in column number 1, it is 4. So of course, we go for the allocation for row number 2. So we allocate it. We allocate 15, which was remaining. We allocate it to stores 1. Now the remaining is 15. So 15 is the demand which is now unsatisfied or unmet in stores number 1. Now again, as we can see here, we have fully allocated row number 2 and row number 1. Now what remains here? Stop. Don't do penalty calculations beyond this. Why? Because we have only 1 row and 2 columns. Now we have only 1 last row remaining which needs to be allocated to stores. Now it would be allocated to those stores which have unmet demand, and it can be allocated only at the cost where the row and the column meet. So here, out of 80, 65 now will be allocated to stores number 2, and 15, that is 65 minus 80, 15 automatically gets allocated to store number 1. So we are done here now. That's it. So this is our allocation. And is this feasible? Yes. To check the feasibility, what we do is we calculate or we count the number of allocations. So it's number of allocations 1, 2, 3, 4, 5. Now M, that is number of rows, plus N, that is number of columns, minus 1 should be the minimum number of allocations that you have to do to make it feasible. So now this is 5. So the allocations here also is 5. So the solution is feasible. Well, is it optimal? Mostly when you use Vogel's approximation method, you come to a near optimal solution. To check optimality, of course, there are other methods. That is, the Modi method is available. Then the stepping stone method is available where you can check it. Okay. You can check it using those methods, and you can also check it using computers, and you will find that this is the optimal solution. So the minimized cost here is 580. Now the minimized cost here is nothing but the allocation, that is 40 multiplied by 2, and you sum it all up and you come to a minimized cost of 580. So that's the end of the lecture, and it was a quick one. Okay, friends, that was all about how to allocate when you have restrictions. Hope you enjoyed this video. And if you did enjoy this video, send it over to your friends and do like and subscribe my channel. And keep commenting. If you have anything, let me know. Goodbye, friends. Have a great day.